Okay, everybody, good afternoon. Thank you for coming to our final day of the altE conference. This is one of our last sessions here today, and we have Russ Ainey from Avid Solar. This is his own installation business, and he has great experience with connected solutions, which he's going to talk about, but specifically the mathematics of residential storage and how you can help your customers in this market as storage starts to become more prevalent and more backed by our utilities and such. So I'd like to introduce Russ. Thank you.
Thanks, Andrea. So let me just hop right in here. So we have a lot to cover in about 45 minutes. So if I fly through this, you don't have a chance to read everything on the slide. Just heads up, I'm giving away the presentation to everybody. There's spreadsheets behind this presentation that I'm not giving away. We can talk about that offline if you need some more support. But the other thing I want to say is, you may hear some editorial comments in here from me regarding the program designs of the various incentive programs that apply to storage here in Massachusetts. Those are just my own. They don't necessarily reflect the intentions, motivations, or anything like that of the policymakers. I'll probably also throw out some speculation regarding pricing and other things. It's worth a grain of salt. It's kind of my best guess at things. So let me just keep on. That's my disclaimer page. So one of the key things I wanted, and for folks that also who saw my presentation December 2020 with through CBANE, this is similar to that. It's been updated, and I get into a little bit more detail. So one of the things that's nice now in Massachusetts is that the incentives, when you add them all together, are sufficient to recover the cost of an energy storage installation, the typical residential energy storage installation, and perhaps generate a return on investment. The key thing, though, is I think, at least you can recover your costs. So it's like getting a free backup power system if you're willing to wait it out for 10 years or so. It could happen faster, and we can get into that. And I'm going to cover several different incentive programs here. The Smart Energy Storage Adder, the Federal Investment Tax Credit, Connected Solutions, and then the Clean Peak program as well. And I'm going to start off with, kind of this graph here. It shows a project that's a DC coupled battery. It's the LG Prime DC coupled to an SolarEdge 7.6 kilowatt inverter and an Energy Hub inverter. And I'm going to say that the incremental cost of adding this onto a PV system installed is about $10,000 for the customer. And your pricing may be less or more depending on your economics, but I think it's possible to do that. What I'm showing here is for the average residential installation that, say, produces about 11,000 kilowatt hours per year, then we would be able to generate a energy storage incentive return of over $10,000, covering the costs of that install, hopefully making the sale of that energy storage easier. Some key assumptions. I'm assuming, so the first line there is wrong. I'm assuming the energy storage is $10,000 DC coupled to install. That's an incremental cost on a PV system, that it's going to produce about 11,000 kilowatt hours per year. And that the 2021 ITC stays at 26%, and that the energy storage has a 5 kilowatt throughput continuous output rating and a 9.6 kilowatt hour energy storage capacity. I'm assuming we're in Smart Storage Adder Tranche 12. That's where we currently are, and for National Grid as well. And so given the specs on the PV system size and the energy storage system I selected, the storage adder in Smart, and we'll go through this, turns out to be around 3 cents per kilowatt hour in today's market. Connected Solutions, I assume that we're going to be running 3-hour events always, which is conservative. The longer the event, the lower the incentive is going to be on average for any given battery size. And that for National Grid, that the rate that I'm going to lock in is $275 per kilowatt. That's higher than the $225 per kilowatt that you may have seen in the past in terms of the average performance during the Connected Solution season. And that's because National Grid, unlike Eversource, took the winter incentive and added it to the summer incentive when they decided they were going to do away with their winter events. Eversource has not opted to do that yet. Then I also look at Clean Peak as another incentive and stacking that on top of connected solutions and smart. With a DC coupled battery, however, I assume that's zero, and we'll get into the reasons why. Primarily, it's because you would need to have revenue grade metering of the DC output of the battery, and no one's providing that metering plus reporting solution to PTS that I've been able to find anywhere. And I also assume, because this is a residential system and it's DC coupled, that this battery is only being charged under the current, Section 25D tax code regulations using renewable energy power, 100%. So that means that if I have a day where I can't fully recharge the battery, then I may not earn my full incentive from connected solutions, for example. I also don't assume capacity markets. However, there is a way to participate in that, specifically the forward capacity market through the demand response programs, passive demand response. But it's a lot of work, and you got to go through a curtailment service provider, generally a big aggregator, and they take about 30% to 50% of the revenue that you might generate. So at the end of the day, it may not be worth the hassle, and there aren't a lot offering that to residential size storage right now. So here's that same system in National Grid territory, but it's not participating in the SMART program. As a lot of you probably discovered, the SMART incentive for National Grid these days for PV is 0 cents per kilowatt hour. So it makes little sense to participate in SMART unless you're trying to get the energy storage adder. But what I'm going to show you here is that it's actually more valuable to the customer if they choose not to participate in SMART, because the Clean Peak storage value for the energy storage incentive is actually greater than the smart storage adder. So here we have an incentive of $11,150. I'll go back. The other one was $10,530. So about $500 more, just looking at the energy storage incentives alone, given my assumptions regarding Clean Peak performance, where the smart certificates are. And one of the reasons why that is when you actually use a smart storage adder in National Grid territory, if you look closely, you'll find that the storage adder is decreased by the base PV incentive, which at this point is actually negative. If you did PV alone, it shows up and the behind the meter value of energy calculator is 0. But when you add on the storage adder, it actually reduces the value of the storage adder that you got from the battery storage calculator. So, so if you skip out of SMART and instead go over and participate in Clean Peak instead, which you can do with very little added cost these days, as soon as we convince SolarEdge to report the output in my situation to PTS for Clean Peak, you can not only get a higher storage incentive, but you can also get an additional $4,000 over that 10-year period of time in the form of REC income for the PV generation, and also Clean Peak certificates that you'll generate from the PV generation during Clean Peak hours. So it's significantly more valuable to the customer, almost 50% more valuable, to participate in Clean Peak and bypass the smart storage program. So smart is rapidly fading into the rearview mirror in Unitil territory, National Grid territory, Eversource West territory, where essentially it's break even right now before you consider the Clean Peak and RECs value. So it's really in Eversource West. The only place where you'll find where smart energy storage adders still make sense are going to be in the Eversource East market, and if you have a low income customer. The other possibility is that if you decide to take alternative on-bill credits instead of net metering for any excess generation, you can find a potential business case to go forward with that approach. We'll get into that in a minute. So the key point is that even for DC coupled systems, it is possible to have an attractive return on investment. With AC coupled systems, it's also possible to get Clean Peak certificates in this other scenario. So that would actually increase the value of this by about, I would say, another $1,300. Remember, if you're in Clean Peak and smart, your Clean Peak incentive value for the energy storage is reduced by 70%. There's that 0.3 multiplier. So it significantly reduces the value of what you would otherwise earn for the same level of performance. So if you take that 2,997, multiply that by 0.3, you'll get a sense for where you come out in terms of the incentive value of the of clean peak certificates for an AC coupled battery in smart. Okay, so that's just a quick overview. We're going to dive into some of the details here. So generally, I think we're all aware that energy storage installations are increasing. Even within the SMART program, more people are asking for the energy storage adder as one measure. DOER had reported out through 2020 what percentage of residential or small PV systems were actually had storage attached. In 2020, it was about 6%. When I looked at the systems that were qualified in SMART that had their COD in 2021, so it's a slightly different measure here, it was up to 8%. And I think that's going to continue to grow at a pretty good pace. I think we'll see 10% or more this year, especially if people begin to realize that through Clean Peak and Class 1 RECs, there's an attractive opportunity out there. One of the things I'm not going to get into during this presentation is the value of a backup resiliency solution for a customer, like the value of food not, going bad during a long-term power outage or something like that. I'll leave that to you. I'm primarily focusing on the incentive programs, and I'm barely going to get through that. So in terms of the backup power value, we're not going to cover that. I'm also not going to recover the cost of an installation, DC coupled or AC coupled. We can get into that offline if you want to, but I'm not trying to cover that at all. I'm really just looking at the math associated with the performance incentives, which I think a lot of people don't fully get or know how to calculate or know how to add up together to arrive at a good business case for customers. I think if many of you did, you'd see that there's a good case for selling more energy storage out there. All right, so forgive this chart, but what it says essentially is that the two most important programs are Clean Peak and Connected Solutions these days in terms of driving residential battery investments. You really need to get your arms around it. Connected Solutions is pretty easy to get your arms around, although there's some complications to it. And Clean Peak is hard to get your arms around. So we'll spend a little bit more time on that. And if you look back at those pies beforehand, you'll find that Clean Peak is 50% in this scenario if you're a non-smart system, and more than 50%, a little over 50% if you're in smart. So even with smart or Clean Peak, Connected Solutions is driving this market, which also means that if your energy storage is not in, I'm sorry, I hit the wrong key. If your energy storage is not, a solution is not in Connected Solutions, you are probably not going to be competitive with some of the other offerings out there. And you're probably doing your customers a disservice if you're not driving them towards the Connected Solutions, qualifying vendors or solutions. All right, so going through the various incentives, ITC for residential storage, that's been extended through this year at the 26% rate, although we continue to see good indications that even though Build Back Better didn't pass, the tax credit provisions within it for clean energy are likely to pass this year. Senator Manchin's supportive of those, and that would increase the incentive to 30%. The other thing that's really critical, is that second bullet point, is that energy storage will be identified as an eligible technology. So it doesn't have to be co-located with PV. It doesn't have to be recharged with renewable energy in order to qualify for the tax credit if these new tax provisions as proposed in Build Back Better pass. That's critical because right now we have this one, it must be fueled 100% for the residential credit by renewable energy. And I'm going to assume that in the modeling that I share with you today, because those are still the rules and tax credits we live by. Although I hope that retroactive to January 1st this year, we'll see the Build Back Better provisions included in the, that essentially will be the tax law that applies for customers in the for any installations done in 2022. So, okay. One thing also, just to keep in mind, there's a lot going on with net metering. The current net metering provisions do not allow battery storage standalone to net meter. You can net meter if it's co-located with a PV system that otherwise qualifies for net metering, as long as if you have an AC coupled battery and that AC coupled battery does not charge from the grid. In other words, the AC coupled battery can only charge from PV to the degree that PV power is available. So it has to be 100% charged from co-located PV. So again, another reason why when I do my incentive modeling, I only look at the availability of PV power to recharge the battery in terms of figuring out how much energy I have to discharge during any event under connected solutions or clean peak. And that's an important constraint that makes modeling a lot harder. Okay, so the smart storage adder, I think I covered some of this already, but the another thing, the smart storage adder, I think was poorly, again, my editorial comment, designed. But when DOER was designing the SMART program, they really could only design a PV performance incentive program. And so they added the smart storage adder in there as a PV production incentive adder. And it really has nothing to do with the performance of the battery and the value of the battery itself, other than this connotation that at DOER that batteries have value to the grid and they were trying to induce investment. But they didn't have the legislation enabling them to offer some sort of upfront storage rebate. Clean Peak came along separately in different legislation with certain requirements. That's separate. And there have been bills on Beacon Hill to actually create and offer a energy storage specific rebate program of some sort, but that hasn't existed. That didn't enable DOER to create something like that. So they use SMART to kind of backdoor in some energy storage type incentive. And that's how they came up with this adder on top of PV generation. That's, essentially it's a certain amount of cents multiplied by your PV generation each year to come up with this. Another thing to keep in mind is that the storage adders go down 4% per tranche. We're on tranche 12 right now, and it's getting less and less for those folks in SMART. Also, because we have large systems now over 500 kilowatts in size in SMART required to add on energy storage, and generally it's 2-hour duration energy storage at over 500 kilowatts. So generally you're looking at more than 1 megawatt hour at a time. There's going to be those tranches are going to get eaten up pretty quickly as we work our way through interconnection issues, and so the value of that smart storage adder, which in our scenario here is only 3 cents per kilowatt hour, could be 2 cents per kilowatt hour by the end of this year. So it's going to continue to go down in value. And in fact, if you look in the Unitil, if you did the behind the meter for Unitil with a 3 cents per kilowatt hour storage adder, you'll find that the total smart incentive with the storage adder is, I think, almost zero already. And you'll see that probably be the case in National Grid by the end of the year, also in Eversource West, perhaps by next year. So SMART is, again, in the rearview mirror. I wouldn't focus much on that. And with that, I'm going to keep going forward. So in this page, I show you how the result in the upper right-hand side in the gray box or green box, whatever color that is, says that the adder amount from the energy storage calculator came in at 3 cents. But after I reduced the negative value of the base compensation, it actually winds up at just 2.2 cents per kilowatt hour. So participating in SMART with PV actually reduces the value of that storage adder, and it's going to continue to get worse. All right, so connected solutions, by far the most valuable. The thing about connected solutions is the utility program administrators continue to reserve the right and have the right to change the terms and the conditions of the program at any time. And we never know what they're going to propose and when they're going to propose it. Thanks to some folks essentially complaining to the Energy Efficiency Advisory Council and DPU, they're now trying to embark on stakeholder engagements or listening sessions for when they want to change things. But at the end of the day, they're not required to listen to us in terms of what they actually implement. However, the EEAC, their kind of overseer regarding the program design, will take perhaps more heed in terms of the feedback that we're providing them. I honestly didn't see EEAC over the last couple of years when we've been dealing with connected solutions and providing feedback, push back too hard on the PAs in terms of what's in the 2022 to 2024 program year proposals. Other than the fact that, was it yesterday or the day before, the National Grid hosted a Zoom call with a bunch of stakeholders in the industry. I got a 1 day's notice with no agenda for the meeting. It just said Connected Solutions, please join us for a public comment session. And so I joined, but most of the people on this call probably weren't even aware that it existed and missed that opportunity. And it's something they intend to do annually, and they may have another one later in March, again on an annual basis. But that's about as much feedback as you're going to provide, unless you get on the agenda for your 3 minutes of public fame at the beginning of an EEAC meeting or submit written comments to them. So at the end of the day, the program administrators have significant control. They still have the power of the pen in terms of what's in these programs. And even though they continue to say there'll be an incentive rate lock, they may determine that they are going to calculate how the performance of a battery is determined effectively lowering the value of any annual incentive you get through Connected Solutions. And the example of this is the baselining approach that they introduced back in April. There was a lot of pushback, DOER especially, and they decided that they were going to waive that notion for measuring performance for this past summer, but it's still on the table. They're waiting for a consultant report to come back and advise them, and it could be in effect for this summer. We don't know yet, or the years after that. And they said that in the call a couple of days ago, that all of the other Connected Solutions devices use baselining to measure the performance of the various assets enrolled in the program, like thermostats, hot water heaters, and other things. And so I guess the notion there is that right now this is a special case, and it's likely that the consultants are going to come back and say we should use baselining for Connected Solutions as well. And I'll get into what that looks like in a minute, but that's an example of how the program administrators can change things. So don't believe that an incentive lock is some type of guarantee regarding the amount of revenue you're going to generate through the Connected Solutions program over that 5-year period. The other thing I think to call out here is that the PAs do indicate that after 5 years, it is extremely likely that the Connected Solutions program will continue, and you'll be able to re-enroll your battery for years 6 through 10, but it will be at a lower incentive rate. In Connecticut, for example, the Eversource just introduced a slightly modified version of Connected Solutions that has both an upfront rebate incentive, it's higher for low income, but they also have an annual performance incentive during the summer, much like we do in Massachusetts. And after 5 years, that incentive is reduced a little over 40%. So in my modeling, I assume a 50% reduction after 5 years versus the rates you get for years 1 through 5. So you should model it out for all 10 years, just assuming some step down rate for the years 6 through 10. The other thing that's happened now is they took away the winter event. So again, another change that they did. Initially, when people signed up for Connected Solutions and thought they were locking in performance rates, is they thought they would have this $50 per kilowatt average incentive rate locked in for 5 years for the winter events. And it turns out that that's not the case, because National Grid and Eversource decided to stop offering winter events altogether. And now Eversource is not making up for it in the summer incentive rate. National Grid is making up for it. They are, so for the bullet point up top there says, you'll see now instead of 225, you'll see 275 per kilowatt of average performance during the summer. That's another key difference between the two programs. So you have to dig into the details. The other question is, are they going to be 2 or 3 hour events? They're leaning more towards 3 hour events, but even that differs between Eversource and National Grid. So you'll have to look at, how long is Eversource running a Connected Solutions event on average? They're not necessarily the same across the utilities. And the longer the event, the lower your average kilowatt performance, most likely, given any battery size. Unless you have a really big battery, most batteries will only have a partial third hour per se. So if I had like a 10 kilowatt battery and a continuous output rate of 5 kilowatts, after a couple hours at full output rate, I'd be tapped out. So the third hour I get 0, and I have an average performance of only 3.33. during those 3 hours. And so generally, I recommend people model it as a 3-hour event. And I think you'll see the utilities moving towards that. The average length of an event during the summer last summer increased towards 3 hours. All right, so that's a little bit about connected solutions, and we'll get into some more of the detail about it in a minute, just to kind of review the Clean Peak program. So Clean Peak applies to not only kind of it applies to smart projects, but with smart projects, again, we have that 70% discount with a 0.3 multiplier. And for the PV output during the Clean Peak seasonal windows, the 4 hours and any Clean Peak event, the PV generation for any smart project counts as 0, because the utilities are able to claim your your Clean Peak certificates. They get all environmental attributes in exchange for your participation in the SMART program. And that's not only your Class 1 RECs, that's also your CPECs, your Clean Peak energy certificates. If you're retrofitting a customer, like an SREC 1 or an SREC 2 program customer, and adding energy storage onto their system, the PV output for that gets a 0.1 multiplier, so only 10% of the CPECs it would otherwise earn, but you get 100% of the energy storage CPECs. If you're a new install, that is anybody installed after January 1st, 2019, then you're considered a new Class 1 system, and if you're non-smart, and you get 100% of both the PV value and the energy storage value. So people that are installing what I'll call post-smart systems with energy storage, you get 100% CPEC value for all of the PV energy generation during the Clean Peak hours, as well as 100% of the value of the energy storage output during the Clean Peak hours. I know that's a little complicated, but essentially what it means is that, if you're in Unitil, National Grid, or Eversource West areas, you probably don't want to sell smart and instead focus on trying to figure out how to put in place a Clean Peak energy storage solution if you're pitching energy storage to those customers. The biggest problem, though, is that with energy storage is that last bullet point on the page, which is that Clean Peak energy certificates can't be earned if you don't have a reporting solution. And that has been a fundamental problem for small Clean Peak systems to date. And in fact, if you look at the small systems currently registered in the Clean Peak program through the end of 2021, the smallest system enrolled is 300 kilowatts in size. There are no small, I'll call it below 25 kilowatt in size systems registered, because there haven't been reporting solutions available to them. That is about to change soon, and there is one reporting solution available for small systems right now, and that's PowerDash. So those who are familiar with Enphase systems, you've used PowerDash in the SREC programs. PowerDash will report with the same $280 per 10-year reporting fee that Enphase charges for reporting, revenue grade metering to, say, NEPOOL GIS. For that same 280, they'll also report that generation to the production tracking system for Clean Peak purposes. But here's the problem with Enphase. They don't have revenue grade CTs monitoring the output of the Enphase energy storage system. And you have to have revenue grade metering reporting for the Clean Peak program. So that means for PowerDash, you would need a separate PowerDash meter that's reporting out just the input and output to the energy storage device above and beyond what the Envoy is reporting. The other monitoring company that is about to introduce a Clean Peak solution is SolarLog. It took me over a year to convince them, but they have committed to providing a reporting solution. And they're the only other ones out there that I'm aware of serving the small market. None of the inverter suppliers are offering a Clean Peak reporting solution yet. DOER assumed that they would. They assumed incorrectly. I've been pleading with SolarEdge, for example, to do this, because an important, through the campaigning by myself and others, an important change was made So the reporting requirements for what I'll call post-smart systems that, where the clean peak multiplier for the PV and the energy storage is the same 100%. DOER now allows for one revenue grade meter to output both of them, to report both of those. Whereas previously energy storage and PV generation had to be reported separately as separate assets to the PTS. So I said, if they're both 100%, why can't we just we use one revenue grade meter, and when we have DC coupled systems as for the output of the inverter, and report the combined total. And DOER conceded on that and changed regulations. They've updated the registration process now at PTS so that you can do that. So if SolarEdge did opt, for example, to use its inverter integrated RGM to report generation of the system to PTS, then it would work. The reason why they don't do that is because the reporting format, it's not just reporting like the cumulative RGM amount at the end of each month. They have to report interval data for every 15 minutes of every hour of the month and do that on a monthly basis. They haven't created the report. They haven't tested out the integration with PTS, even though it's not that hard. What I really need, or what we really need, is more folks to tell their inverter manufacturers to please, damn it, have your RGM report to PTS. For clean peak, you cannot have manual reporting to PTS on a monthly basis. So say, in the past for class one and for the SREC 1 and SREC 2, you could have manual reporting if you had a 10 kilowatt DC system or smaller. You could just get on each month and type in what the revenue grade meter showed. You didn't need an automated reporting service. For CPS or clean peak, you must have an automated reporting service. They will not allow you to manually upload a spreadsheet or a CSV file that has even 15-minute interval data. You might be able to put that together from, Enphase or Clean or any of the other inverter manufacturers and put together a report for every 15-minute interval, but you can't upload that yourself. It has to be provided through an automated reporting service. So again, I ask you to reach out to your inverter manufacturers and ask them to do that, because now more than the majority of residential service territories in Massachusetts are what I'll call post-smart and unable to participate in clean peak, and therefore leaving a lot of energy storage incentive on the table simply because we don't have the dang reporting solutions. And if you think DOER is going to help you with that, I've been pleading with them to outreach to these customers or to these inverter manufacturers for more than 3 years, and they've done very little of it. The other thing you should know is DOER lost both Will Lowers and Amy McGuire, the number 1 and 2 people that designed clean CPS, to the private market. They've left DOER. Currently, they've taken the emerging technology division and collapsed it. It's no longer there at DOER. So there's a staff of folks there to manage the CPS registration process. It's less than 1 FTE probably given the volume, but I'd like to pump up the volume by getting more reporting available so that more systems can participate. Okay, I'm way over time. I'm going to keep going here. So the Clean Peak standard, another thing about Clean Peak is the value of a Clean Peak certificate, or the number of Clean Peak certificates you can produce, varies significantly throughout the year. The spring and fall are particularly not very attractive unless you're trying to hit the ISO New England peak during the months within the spring and fall period. And that would be primarily October and November and March and April. If you can target the peak hour for the ISO New England grid for those months, it may be worth discharging the battery to try and earn some Clean Peak certificates. You get a 25x multiplier plus your 1.5x resiliency multiplier during that peak hour if you can hit it right and fully discharge your battery during that hour. Otherwise, it's probably not worth the cost of the degradation of the value of the battery for participating in the program during the spring and fall seasons. The summer and winter, however, are of value. But we have different strategies when thinking about how and when to discharge, especially if the Connected Solutions program begins to introduce baselining. And I'll get into that in a second. All right, so this is an eye chart from DOER. I'm not going to even try to go by it. It's hard to figure out how to model all this. at the end of the day, it really requires you, especially if you're DC coupled, to do an annual hourly model of your expected PV generation, and then to work with that to come up with an annual hourly state of charge model for your battery, and to determine how much battery energy or kilowatt hours you have available to discharge during any event for the events when you want to discharge. So another thing is, when do we think those ISO New England grid peaks are going to hit? When do we think we're going to hit those 25x multipliers? What's the probability of doing so on any given season? And they designed the Clean Peak program fairly well to hit the clean peaks. There's always going to be a few months, a month or two in a year that's going to go outside of these windows. That is for the ISO New England peak for that month. It's likely they go outside. But for example, in 2018, they hit those yellow boxes demonstrate that they hit every single hour within those event windows. So it is there's a good chance that you could get those 25x multipliers during the spring and fall months. That said, probably the most volatile or months where it's most likely to be outside of the normal range is during the fall months as well, because of the way the load curves work and our ability to have these crazy hot days during the spring and the fall that throw things off. Okay, so how do we go about figuring out how much energy you're likely going to be discharging, therefore how many CPECs? Again, you really have to go through a modeling event. And then again, I recommend, assuming you're going to have a 4-hour event for clean peak, and that you discharge your battery probably at its peak output rate for those 4 hours based on the available inverter capacity. Let's see. Another source to figure out when you think those peak hours might be, to kind of figure out what you think the probability of hitting them might be, and also what the coincident PV generation might be, is CPS is now producing actual ISO New England peak load tables. So this is a 2021 table. They have one for 2020 as well. You can get more historical data through ISO New England. But you can see here in this table right here, 7 out of the 12 months last year had their peak hour during the hour ending 6 p.m. So that'd be from 5 to 6 p.m. Discharging your battery, if you're going to do it, nothing else, that would be the time to do it most likely. You're most likely going to hit your peak if you discharge your battery year round during that period of time. But I suggest you change that schedule seasonally according to the clean peak windows. If this, again, this is a bit of an eye chart, but what I'm trying to provide a reference to, and you can read it when you get the presentation, is that you can go back and get the hourly data. You're looking for the SMD hourly data, the little red arrows point to it, and you can get them for the full year. And that provides for every hour of the year what the system load is. And that's the figure, the highlighted yellow column on the far right down, though, if you open up those spreadsheets that you're looking for, and you want to figure out when is the peak hour for a month and what hour did that happen to be in. And you can look at several years to get a sense of trend lines and when you might want to target discharging that battery. In the, and this is just saying you can get hourly PV reports. People are like, well, how do I generate an hourly report? Most of my software just tells me monthly PV generation. That's not really true. If you look hard enough, both PV Watts and Aurora allow you to download hourly TMY based generation for the entire year for the first reporting year. And so if you look for it, you can find it. Then you just need to figure out, hey, is it hour beginning or hour ending? It's hour ending for Aurora, so that lines up nicely with the ISO New England data if you're trying to use it to compare it to that. But there's another issue. The TMY data that we use for those annual or even hourly simulations, typical meteorological year, is kind of weird data. It's not an actual average of last 10 or 30 years. It's they look at a monthly average or median amount of kilowatt hours they expect to be produced, and they find the best year, depending on the TMY data set, that fits that, the one that has the least errors in terms of looking at the distribution of days for that hourly total for the month. it's a little complicated, but just note that the TMY data already kind of fills in a little bit of the overcast or rainy days, right? So it's already factoring in weather performance. What it's not doing a good job of at all, especially if you use TMY3 data, is it's not at all factoring in snow cover, which is a major factor here in New England, especially partial snow cover. The TMY2 data, which is older data, does allow you, if you want it, to use to look at snow coverage data, but you have to use the SAMS modeling software to be able to factor it in. Aurora won't take it into consideration, nor PV watts. Instead, if you see a snow coverage factor to discount the output of your crap, I'm running out of time here, to look at the to look at annual production, what it does is it actually uses a linear average for every hour of the month, a linear derating for every hour of the month, based on your annual monthly estimated snow coverage, or even on an annual basis. It's like a shading factor. It does a very poor job of actually simulating when and how much snow is going to be inhibiting the output of your system. All right, guys, I'm going to keep flying through here a little bit. Lots of factors to consider. So one of the things I recommend is for the months of July and August, especially because I do believe baselining is likely going to be implemented in the performance measurement for connected solutions, is you allow connected solutions to guide the discharging of your battery during those months. Because one of the things you'll see is that the connected solutions event hours are generally within the clean peak event hours. So you kind of get a twofer. You get the clean peak certificate hours as well as the connected solutions hours if you let connected solutions drive the discharging of your battery. Because once you've discharged your battery, you're done for the day for the most part in terms of trying to participate in clean peak subsequently. So that's important. The other thing is if we introduce baselining, which is a look back technique, what baselining essentially says is that we're going to look back for the most recent 10 days where connected solution events didn't occur, and that can include weekends or days in, say, June or May when there was no connected solutions event, and say, what did your battery discharge during the connected solution event hours, typically late afternoon, without a connected solutions event. So if you're doing like a maximize self-consumption of solar where you're discharging your battery every evening, you're going to screw yourself if you try to then maximize connected solutions revenue, because it's going to say, hey, you've been discharging the full amount of your battery every evening, so your net additional amount that you're discharging through connected solutions is zero. You don't want that, right? So you want to make sure that leading into, before we even arrive at a connected solutions season, which is really from July through August, even though they say it's May through September, June through September, they won't have an event in June or September unless they think they're going to hit the annual ISO New England peak due to an extraordinary heat wave. That happens very, very rarely. It's almost always during July and August. And so, so that means like for the last 10 days of June, even if you're trying to generate clean peak certificates, you should not be discharging your battery in the evening hours. This is also an issue for folks that are using DC coupled energy storage to recover clipped energy. To recover clipped energy, you have to discharge your battery each evening or early morning to some degree to create enough battery kilowatt hour capacity to absorb that clipped energy during the middle of the day when your inverter otherwise might be clipping. So you have to be careful. I recommend, since they're not going to have a connected solutions event in the morning, that you discharge your battery first thing in the morning to make at least some capacity available to capture that clipped energy during the middle of the day. All right. Wait, sorry, I went to the end. Crap. What did I do? Hold on, everybody. Apologize. Let me get back. Okay. Yeah, so another thing here is the peak hours during the day tend to be moving as we install more solar to later and later in the day. I'm going to skip through this. This is more details around in clean peak. We can get into that a little bit. But one of the things, if you have a DC coupled battery, is the DC coupled battery inverters almost always I don't think this is a parameter, for example, you can even change in a SolarEdge inverter. They will always default to prioritizing PV generation. So say the Connected Solutions event was, started at 3 o'clock in the afternoon and went to 5 o'clock in the afternoon. You're still producing solar power on that hot summer day during those hours. And so to the degree that solar power is being generated, that means you don't have much excess inverter capacity to discharge your battery. And you may find that over that 3-hour Connected Solutions event, you're unable to discharge the full amount of energy you have stored in your battery, and that can limit your output. So that's something where the hourly state of charge model combined with your TMY hourly simulation will help you to determine more reasonably what the amount is. Okay, my timer went off, suggesting that I have only
go for 5 more minutes. Russ,
a few
that's
more
fine.
minutes here.
Yeah,
okay,
that's fine.
So determining the monthly CleanPeak standard peak hour is hard. And again, I would recommend using a probability basis for each month if you intend to participate. Again, I don't recommend participating in the spring or fall seasons, largely because the degradation of the battery from cycling the battery on a every weekday is probably not worth the value of the CleanPeak certificates. So your battery is, if you just put your battery on the shelf after 10 years, typically it's going to lose capacity even without cycling. And if you cycle it, especially if you cycle it hard and fast, it's also going to lose capacity. And to a degree, it's prorated based on how much you cycle it or how hard you cycle it. Getting good algorithms for the energy storage providers, the battery providers, regarding what that looks like or how to calculate that well, is impossible. I plead, the engineers just won't share it. Every situation is too special. And so they don't feel comfortable sharing anything. And we don't have like STC data like we have for solar modules for energy storage in terms of performance or degradation rates over time. You may see some curves out there that show, LFP batteries don't degrade as quickly as, say, NMC lithium-ion batteries. And that may be true, but even within LFP batteries, there's wide dispersion regarding how much capacity you have after several years, depending on how you exercise it in the environmental conditions. What really kills the batteries is high heat. So also if it's in a hot space, you're more likely to, or poorly ventilated space, you're going to degrade your battery faster. So there are a lot of factors that go into it. But I think, the point here is that also if you participated in CleanPeak year round and you're cycling the battery over 200 times per year to participate in CleanPeak for all seasons, your battery is going to degrade faster than, say, if you just participated in Connected Solutions and you were discharging your battery only 50 to 60 times per year. That kind of makes sense. So that's something to factor into. So that means that, if you're exercising for CleanPeak, not generating much revenue for it, and you're degrading your battery faster, that means you have less capacity for the next Connected Solutions season where you really want to maximize your performance. So you got to look at the fact that Connected Solutions is generating more than 50% of your expected incentive revenue over 10 years. You want to really preserve your battery to perform well during those events. And sometimes CleanPeak, daily cycling, or other daily cycling programs can impede that performance or inhibit that performance. Okay, Andrea, I'm going to call a timeout now. Again, I'll share all these notes. Guys, I'm not going to be sharing all of my spreadsheets that I use to do this, but I can provide some additional consultation on the side regarding how to do this. And then if somebody really needed a spreadsheet on a consulting contract basis, maybe I can sit down with you and walk you through how you can put one together or
Okay.
how to take
Thanks,
one of mine.
Russ. I mean, this was absolutely valuable information for everybody. We do have 2 questions in the Q&A. I don't know if you can see that or if you want me to read them to you as well. Everybody, Russ will be in the open networking session right after this, so we can continue there if we don't address it here.
Okay, I can see them. I see from Ben, it says, does
Yep.
the 10,000 install cost include the total install cost, or is it after a mass incentive? For me, I believe, depending on the situation, that could be the total installed cost. Again, your install cost and the customer specifics may make that higher or potentially even lower. I would say in the past, it's generally been a bit higher, but right now, when I look at the incremental cost of doing that with a DC coupled system, just relying on a priority loads panel and the relay and the energy hub inverter. I might be able to get that installed for $10,000. But you're right that it can be as high as $15,000 when looking at that. As you increase the scale of the battery as well, and I think battery sizes will go up over time, so say towards a 20 kilowatt hour battery, you'll find that the dollar per kilowatt hour installed cost goes down. So I think that, if you were to use this to say, well, how does that apply to a 20 kilowatt hour battery? Generally, again, you'll more than recover the cost because the cost per kilowatt hour goes down, whereas the performance is more directly related to the dollar per kilowatt hour installed rate. So, hi, Chris. Nice to meet you too. Good to see you. Thanks for the presentation. Has anyone noted the Connected Solution Program requires their participant to dispose of or recycle the lithium-ion battery pack? I don't believe that is a requirement currently, Chris. I know there are companies, there's a company out of the Green Labs, startup efforts in Cambridge, and there's another one on the West Coast that are specifically designed to take those lithium-ion batteries and either give them a second life as part of some grid integrated energy storage facility, or to grind them up into what they call like black goo or powder for more easily recovering the valuable elements that are inside of them. So I know that that is out there, but I don't think any of our incentive programs require that right now. All right, so David asks, on your advocacy, Eversource did Connected Solutions pilot in New Hampshire, but stopped it. I don't know actually, David, whether it was Eversource stopped it or the PUC stopped it. The New Hampshire PUC made a very unpopular decision to significantly scale back on the New Hampshire Saves program. And this baby may have got thrown out with the bathwater. You need to really appeal to your state reps and senators who can put pressure on the PUC or directly comment to the PUC that you're not very happy with their decision. Eversource would like to offer this up in New Hampshire. Connected Solutions is available down in Rhode Island. If National Grid succeeds in selling Narragansett Power, we don't know if the new buyer will continue it. Eversource did introduce a new program that's like this. It's kind of based off the MESS program in Connecticut, but with an important enhancements for low income, as well as an upfront battery rebate that's based on feedback they heard from the marketplace. So I recommend you look at the Connecticut one as well. For the New Hampshire market, the other group that I would say that is informed about New Hampshire is the Clean Energy Group. I think they're based out of Waterbury, Vermont, or Montpelier, or something like that. And Todd Alinsky Paul has been a key advocate. He's been putting out white papers and proselytizing the Connected Solutions program everywhere. Applied Economics has been providing business cases to demonstrate how there provides a return to all ratepayers. All right, another question. Anything else? So, I'd reach out to Bill O'Connor, David, and it's william.o'connor@eversource.com is the connection for Connected Solutions at Eversource right now as the person. And any other questions, folks? I think we're kind of turning into a pumpkin here.
Excellent.
And again, feel free to email me or give me a buzz if you want to talk more about this. And
Hey,
I'm sorry I had to fly through this. There's a lot to cover.
Okay.
I know.
Yeah, so you'll be in the next session, and
I will.
we'll continue this at 3 o'clock, everybody. So great conversation. Thank you so much, Russ and everybody, and we'll see you guys in a few minutes.
Thanks.